Been having issues with my Unifi setup for quite some time now. Things are not working reliably, speeds are impacted, devices disconnect randomly. I've been running the same configuration for the past 5 years or thereabouts since I first purchased this device. But in that time period, I've made a lot of changes on my UDM Pro, right? I've messed around with it, I've enabled third-party applications. I've done so much on this device that any number of these things could be causing my problem. So instead of trying to figure out what's causing my problem, I'm just gonna blow it all away, start on a clean slate, no backup and restore, because with Unifi you can back up your configuration and do a restore. I'm going to be setting up everything from my VLANs. I'm going to be setting up IPv6 for my Thread devices. I'm going to be setting up my VPN for my teleport on my phones and laptops when I'm not at home. I'm also going to be optimizing my Wi-Fi. And I'm going to bring you guys on the journey on how I set up my own network. Other people have different ways they prefer to set up theirs, but this is my own setup. All right, let's get started. But first, I need a cup of coffee. I recently upgraded my internet speed from 1 gig to 1.5, and I have direct fiber coming into my home. So which means in theory, I should be able to use the fiber and bypass my service provider equipment altogether and just plug it directly into my UDM Pro. Although I was able to get the GPON to work with my UDM Pro, but it only negotiates to a maximum of 1 gig. My UDM Pro only supports the copper port for 1 gig, and then there's the SFP Plus port that supports 10 gig. In theory, you should be able to support anything between 1 gig and 10 gig with the supported SFP module. For some weird reason, it would only negotiate to 1 gig, even though my ISP is capable of up to 1.5. This ONT SFP actually supports 2.5 gig speed. Unfortunately, it does appear that the UDM Pro does not support 2.5 gig on the WAN 2 SFP port. And apparently software updates were supposed to fix this, but 3 years later, I've tried it, it doesn't work. So I don't know. Do you guys have any experience with getting your UDM Pro to work with 2.5 gig SFP port? Because I've tried everything and nothing seems to work. So unfortunately, I'm going to have to resort back to using my service provider's equipment, using it as like in a bridge mode. So my SFP will connect to my service provider equipment, and then I'll connect the 10 gig port on my service provider gear directly into my UDM Pro, so I still get my 1.5 gig upload speed. I'm paying for 1.5, so I really don't want to cripple myself. Unfortunately, this is going to be a little bit ugly because this kind of makes my rack a little bit of a mess. It adds up an additional equipment into my setup, which I would really like to get rid of. The only other option would be to replace my UDM Pro to like the Pro Max. The Pro Max does have a 2.5 gig copper port and also 10 gig SFP, so that will or should work in that scenario. But that's copper ports though, so. Alrighty, now we're going to be diving into how I set up my VLANs and subnets for my smart home, and more importantly, why I do things the way I do, because there are a couple of different ways you could go about this. But first things first, what are VLANs? Now, think of VLANs like, say, in a school, right? In a school, you have classrooms, and in classrooms, you have students. In this case, the classrooms are like the VLANs, and you can have a bunch of different devices inside all of the different classrooms. So one classroom can have like all of your cameras, and then you can have another classroom that has like smart switches and sensors. These two classrooms, or students in these classrooms, cannot talk to each other. The only way they can talk to each other is by seeking permission from the principal. In this case would be the UDM Pro, which is the router. So they are going to be very much isolated and they need permission. And if the principal says, okay, it's good you can have your conversation, then yes, it will allow that traffic, which is where the firewall rules come into place. For now, we're just going to focus on setting up all of the different classrooms. You don't want to jump the gun. It's very important to make sure that everything works properly first, else you're going to be chasing your tail trying to figure out what's going on. So we're going to dive into how I set up my VLANs. When it comes to setting up VLANs, there are a couple of different methodologies or approaches that you can take. If you are extremely security conscious, you can set up VLANs for every single different device types and functionalities. or you can set up based on your risk assessment levels for each of these different devices and kind of group them together into VLANs, or you can group them based on functions as well, right? So group your media devices, your thread border routers. So you just have to come up with whatever plan you think works best for you and what works with your risk tolerance level, the size of your network, the type of devices you have, right? Let's dive into my Unifi console here. Now, if we look over here, you can see that I have a couple of different, Unifi systems that I currently manage here, and they all have a little bit of slightly different approaches here. If we look at this guy right here, right? If we look here, this guy has a Unifi setup of 16 different Unifi devices, right? Doorbells, power amplifiers, cameras, access points, PDUs, right? And then if we go to something a little bit more simpler like this guy, it has just 3, which is just one switch, an access point, and the UDM Pro. And then we can go to something, in the middle point of both of them, right? That has just 8 devices. It all comes down to how you want to set it up. Now, if you look at this setup, this guy has over, 93 different devices, all consisting of different types of setups, right? And if we take a quick look at the VLAN setup here, you can kind of see that it's just main IoT camera, basement suite, MGMT native VLAN, right? And if we do the same thing and head over to this guy here, if you look at this one is a little bit more granular, right? That's media in this one, and then this one has guest here. So because again, in this setup, there's a lot more media stuff in this one, right? You can see this, the amplifiers here. We have PlayStation 5 here, right? 2 PlayStation consoles. We have a lot of Sonos speakers, AVRs, right? So it kind of makes sense to kind of have a media network. So for my VLAN plan, here is the typical basic structure I set up for my own setup, right? We have the main one. Now the main one here is usually for phones, laptops, Apple devices, NAS boxes. It's kind of considered the secured VLAN, right? Then we have the IoT VLAN, which is all the smart plugs, light switches, sensors, bridges, hubs, all that kind of stuff that I don't really trust. My trust level is a little bit lower on those ones, and the ones that that need cloud access and I don't control them. Over here, I have neighbors that I share internet with, so I have a separate VLAN for that specific use case. I don't want them sharing accessing my stuff, and I also don't want to access their stuff. Or if you have guest network, for me, I have decided not to put in a guest network in my house because I don't have guests that don't need full access into my home, right? Most of my guests are usually close family friends that need to be able to control things in my house, right? So if I have a party coming up soon, then I spin up a guest network in anticipation and preparation for the party. And once the party is over, I kind of just take it out of my network just to keep things clean and simple. And then I have the ones for camera VLAN. Now this is where all my security cameras go into, and even my NVRs, like scripted doorbell cameras, all that kind of stuff, right? They go on the camera VLAN because this VLAN has a slightly different policy applied to it when it comes to access to the internet. All right. For demo purposes, I've set up a brand new UDM Pro that doesn't have any active configuration on it. Although there's just the UDM Pro, no other device on it currently set up. So if I need to do any setups that requires using devices like access points or live environment, then I might jump through one of my other active environments to kind of show you guys. But for the most part, the basic configuration can all be done from within the just with your UDM Pro to begin with. This is the very first thing you see when you open up or you spin up your UDM Pro for the first time, right? It has this quick dashboard layout that kind of gives you an overview of your entire network, right? You have like a overall network health statistics, right? When something is being used, right, you can kind of see what's going on with traffic wise. But if we look over here, you see there's nothing in use here, so I don't expect to see anything from traffic, right, from even both the Wi-Fi health, because there's no access point as well. And over here you can see I have like the default my one IP address, but don't worry, this is just a demo IP address. So if you think you're going to use this to get into my network, good luck with that, because by the time this is going up this will not be active anymore. So if I take you to a live environment and to kind of show you what it kind of looks like, right, you can kind of see the transition graphs here. You see all the uploads, the downloads, you see all the devices that are, so you can see I'm currently on my laptop right here, which is why this guy is actually being highlighted right now, and that's 3 gigs of data has actually been going up and down right now, and we can kind of see the Wi-Fi connectivity health as well. So I'm going to head back to my lab environment. So first things first is we want to create our VLAN. So we're going to head over to the settings section. This is where we do all of the configuration, right? On the top left corner of the screen, right, this is where we do everything related to Wi-Fi, network, and internet.
So for the internet part of things, this is where you do your basic setup for your ISP or service provider equipment, right? Mine uses DHCP, which is, it just pulls it. I just connect it to my, my network, my service provider, and it automatically pulls an IP address. If you had a business network, then you might need to use like a static, and then your service provider will give you all this information. But for most people, DHCP, version 4 will work just fine. The thing that will probably vary for other people is the IPv6. Thread needs IPv6 to be able to, do its thread border routing, right? And we're gonna need that enabled, but you do not need that set up on your ISP provider side of things, right? So you don't need to enable these parts to use thread. But for me, I like it enabled, but we'll come back to that a little bit later on. Let's go back and add to the network and set up our networks. The first thing you see on Unifi is that it's a default network that comes with all Unifi setups, and you can't really do anything about this guy here. It's just the default that your Unifi platform uses. So every of the Unifi applications, this is everything they use by default to get your device communicating and going. But the plan is to abandon the default network. Best practice from the industry perspective is you don't want to use your default VLAN of 1, right? This guy has a VLAN 1, and you really don't want to use that VLAN because it is very susceptible. Everybody knows that it's like using password 1 or using 12345 or using admin as your password when you buy new equipment, right? Everybody that wants to attack you kind of already knows this. And also it's kind of like an industry default, so it's best practice to always change that. So first things first, we'll start by creating a whole new VLAN, and just like the sheet I gave earlier on, right, we're gonna go ahead and create the main VLAN, and we'll assign it to our UDM Pro, right? That's my router. And then for the zone, we're gonna address firewall a little bit later, because with the firewall rule, this is how you actually control traffic between your VLANs. We're not going to deal with that yet. We want to focus on getting everything working first. So I'm going to keep everything on the internal zone. So anything that's on the internal zone will all work by default. Next thing is the protocol. We have the IPv4 and the IPv6. So we're going to select IPv4 for now. Auto scale, I don't like to enable this one. So what that does is it expands your subnet, because by default, a subnet, when you choose like a 24, it gives you access to 249 devices that you can have on that, just that one subnet, right? If I change it to say 19, right, that kind of increases the number of available IP addresses. The lower the number of masks, the more devices you can get. So if I go to 30, right, it's just one device. Just leave it at 24. And I don't like to auto scale because I don't want more than 250 devices on one VLAN. I should never have more than that on a VLAN, or even up to that on a VLAN. If you have that, then you have a problem. For Unifi, it always tries to give you auto settings. I don't like to use anything auto when it comes to Unifi. The auto sucks. So I'm going to enable manual, and then we're going to give it a VLAN ID of 10. Now, VLAN ID is how the switches communicate or identify the VLAN. When the UDM Pro is communicating with the switch or with any device on this VLAN, they use this tag of 10 to communicate with each other. The next VLAN will be 20, so that's how they're able to know what is what, right? Kind of try to match this number with the IP address third octet, right? So I use 10 here, and then I also use a VLAN ID of 10. It kind of keeps things a little bit clean. And then when it comes to isolating network, we don't want to isolate the network on this guy. You probably only want to use this when you have a guest network. I want all of my devices to be able to communicate with each other. So don't enable this if you want them to be able to communicate with each other on the same VLAN. And of course, I want internet access for those devices, and you can enable content filtering if you want. IGMP snooping and multicast DNS are extremely important feature when it comes to every modern smart home network. I'm going to explain this concept a little bit later after we've set up all the other VLANs, because I'm going to use an analogy to better explain them. But for now, my main VLAN, I'm going to enable it here. I'm going to enable IGMP snooping and multicast for now. And then we're going to head over to the DHCP, right? Because my UDM Pro is my DHCP server. You have the option of using other DHCP server. You can use AdGuard, you can use Pi-hole, but I'm using my UDM Pro, so we're going to keep it as DHCP server. If you're using something else, then you can enable DHCP relay. But again, this guy is the DHCP server. And one thing I like to do is I like to start my DHCP range from 20. Because what that does is that it essentially frees up everything from 2 all the way to 19 for me to set up as static IP address. And so when I have things like, servers, like my NAS boxes, like my Plex server, Swag reverse proxy servers. All of those, I usually like to give them static or fixed IP addressing. There's basically an address that never changes. Whenever I need to reach those devices, I don't have to keep trying to remember what IP address every single time because it has changed. This DHCP server, when a device connects to the network, will give devices IP address starting from 20 all the way to 254. So anywhere in that range. So if I connect my iPhone to the network on the main network, it will give it something maybe 150, 200, basically anything in that range, right? And I like to enable DHCP guarding. Now, DHCP guarding is something that's more from a security standpoint. There are two implications of, when DHCP goes wrong. Somebody can come in and bring like a DHCP server, like, knowingly and unknowingly, it can kill your network. So someone that doesn't know, you buy like an off-the-shelf routers off of Amazon, and then someone brings it into your house and plugs it into your house. Those things tend to have DHCP server in them. Once you plug it in, now they will start acting as a DHCP server. And then when your phone, your laptops, or your smart switches try to join your network, that guy will also try to give those devices IP addresses. And what that essentially means is that now those devices now become part of that new switch or router that you bought. It becomes part of their network and not part of your home network. And what that means is that those devices will not work properly. Things will break, it might not even work at all. And the second part is if it's a malicious attempt. So it's someone that actually wants to attack your network, especially an enterprise environment. You come in, you kind of create your own DHCP server, plug it into the network, and now every device or every employee that comes in and tries to connect, they get handed over IP address from this malicious attacker. And now all of this, everybody on the network joins that person's network instead of actually being part of your enterprise network. So I like to enable DHCP guarding, so it will only accept DHCP from my own server. And it will be basically whatever your gateway is, which is this guy here, right? 10.1 is what's going to be here, 10.1 as well. So if anybody else comes in and tries to bring in like any other DHCP server into my network that I'm not aware of, or say something that I did not know. And then another thing I like to enable is my ping conflict detection. So essentially when DHCP server, when it's handing out IP addresses, it checks to make sure that something else is not using that IP address, especially from a static addressing perspective, right? Say for example, I made a mistake, and when I was given a static IP address, I gave another device like a 10.30, right, static IP addressing. This guy doesn't know that I've done that, right? Because I statically addressed it or gave it on that device itself. So what it does is it does a ping check. So it pings that IP address first, make sure that there's no response from it. If there's no response, it most likely means that the IP address is not in use. Right, then it can actually assign it to that device. Another thing I like to do is also this guy here. It's basically if you're using local DNS, right? So you want to be able to say, so for example, if I say tider space dot local, for example, right? Then that way I can basically say, like if I have like a home assistant on my network, I can say home assistant dot tider space dot local to reach my home assistant setup without having to type my IP address. Or I can say, if I have cameras, right, I can name all of them and use this same domain name and say, back camera dot whatever, right, and I can reach it. Once we're done with that, we'll add that network there. So we have our main. Now we're going to head over and create the next one, which is the IoT network. We're going to do the same thing, IPv4, disable auto scale. We'll call this a 30 network, and then we'll change this to manual. Call this 30 VLAN ID. We don't want to isolate the network. Allow internet access, none. Enable IGMP snooping as well, and multicast for IoT as well. DHCP server 30. We'll change this to 20 again, and then we'll enable DHCP guarding, and this time around 192.168.30.1, which is basically, like I said, it's your gateway IP address. Once we add that in there, now we have our DHCP guard. Show the option, enable ping conflict detection. I think I messed up a little bit on this guy. This should be 20, not 30. So we're going to change that to 20. That's the beauty about this. You can always come back and quickly change all of that. Then we'll create another one now for the camera VLAN. We'll disable that as well. We'll call this 30, and then manual VLAN ID of 30 as well. This is the camera VLAN, so we're gonna disable internet access. My security cameras don't need internet access. I'm going to disable that. And then I don't need IGMP snooping as well. Depending on the type of cameras you have, you might need multicast DNS and IGMP snooping. If you have Unifi cameras, you don't really need these options enabled. But if you have like Reolink and all these third-party applications, then you might need to enable these options. I'm just using Unifi in this setup. We're going to disable both options there. Then again, come down here and then 20 as well, enable DHCP guard 192.168.30.1 and add my gateway there and then show the options. All done. So we can kind of see that we're starting to populate all of our networks. Actually, we'll just create one for guest. Actually, just for those of you that want to have guest network. So we'll call this one a 50, manual 50. In this case, we want internet access. For guests, enable this option. Devices on this VLAN are treated like separate VLANs. So say if your friends come over, you have 5 friends that join this network. All these 5 different devices will not be able to talk to each other. So they won't be able to see each other on the network. And of course, you want to allow internet connection. You can decide if you want to enable content filtering. In this network, you don't need multicast or IGMP snooping on the guest network. You're not expecting to cast or do any of those sharing stuff into your network, so we'll disable those. Same thing, DHCP guarding 192.168.50.1 and then add it. So we've created all of that. Let's see what else we're missing. So we can see we're missing, we have to create our management VLAN and our native VLAN. This is our management VLAN that will be the IP address for all of our Unifi network devices. We just call it MGMT. I like to put this at the bottom of the pile. 100, no auto scaling, manual, same idea, 100 as well. And then this is our management VLAN. We don't want internet access. There should be no reason for your management interface to access the internet. I'll disable internet access on that guy. You don't need IGMP snooping. You don't need MDNS. I mean, realistically, this shouldn't really matter, but we'll just apply the same principle across board on this guy here. And then for DHCP guarding is also very important on this guy because this is where all your devices live. I'm on my home network right now. I can go down to 192.168.1.1. That basically takes me to my Unifi interface. Now all that's stopping you right now is just brute forcing the username and password. I mean, there's multi-factor authentication, but every single step you can put along the way to minimize or make it much harder always helps, right? So the same thing to all those gateways you created for all the different VLANs. All right, so if I do .20 as well, right, that takes me to, if we do .30 as well, they're all pointing back to my Unifi gateway, right? So I'm going to head back here and then we're going to do again the DHCP guard, right? So you want to make sure you're creating a separate VLAN for all of your Unifi devices. If I go down here, you can see that everything here, my Unifi switch, it's a different IP address. My access points, they all use in a separate VLAN, right? Other than the Dream Machine Pro, which I can't change. Anything that has to do with, any of my management or network infrastructure, they're all part of my management VLAN. So let's head back to configuring our networks. 100 right there. /24. Realistically, I don't need a /24. I can reduce this to like a 29. Or maybe even a 28, right? I don't need 24 IP addresses because I'm never going to have 250 management devices. So I can bring it down to /28, change it to a manual, and then we can kind of just use our VLAN ID there. And of course, we don't want to enable internet, so we'll disable that for our management. We don't need IGMP snooping. We don't need multicast. And of course, we need DHCP guarding. Always need this feature. At least I personally like to enable that all the time because I don't like to take chances. And then we can just add that. Now we have our management network. And finally, we need to create our native VLAN. I'll just call it native. In this case, like I said, we're putting everything on internal for now for our zone. So there shouldn't be any rules. Same thing, I like to put it at the bottom. It doesn't really matter. We can also scale it back down to like a 30, right? Because all we need is just the one IP address. I'm just going to, put it at 29, 5 usable IP addresses. And then same idea, 101. We want DHCP guarding. We don't need to worry about that on this guy because it's basically an untagged VLAN. All it's doing is just allowing communication between all of our Unifi devices. So it's not going to be doing much. So we'll just add that. That's our native VLAN right there. So we have native, management, guest, camera, IoT, main. This guy is going away. So this guy, the native, is going to be replacing this guy, our default of 1. We're going to make it 101 instead. Now we have that all set up. Now, remember when I was talking about multicast and IGMP snooping? Now, when you have an iPhone, you open up your iPhone, you want to play to your Sonos speakers, right? You open up Spotify on your iPhone and you have this music you want to play. All of the Sonos speakers, if you have like 4 of them, multiple of them, they will all show up in the app. How that happens, or what the function that makes that work, is called this MDNS. That is how your iPhone is able to discover all of the Sonos speakers. And then that's how the iPhone will be able to play to all the Sonos speakers. Or you wanted to do AirDrop, for example, you open up your phone, you do a search, right? And then it discovers your laptop or other phones. Same thing. Multicast DNS is how all of those operations work. By default on Unifi, each VLAN itself has multicast enabled by default. So if I'm in the camera VLAN itself, multicast is going to work within the VLAN. If I have a phone here, 2 phones on the camera VLAN, they'll be able to see each other. Say if I had a phone on main and I had one on IoT, by default that doesn't work. So they won't be able to see each other. So if you want to enable that feature, you have to do it by enabling the IoT auto discovery. But we have to be very selective on how we enable this, because multicast can be a problem as well, because it's always constantly sending a ton of packets throughout the network to multiple devices at the same time. And this can lead to a situation called multicast flooding. And when that happens, that could actually kill your device. Like I was having problems with multicast flooding that was always killing my U7 Pro. I have so much multicast devices. I have the HomePod minis, doorbells. I have Scripted that does to all my cameras. I have Sonos speakers. I have so many IoT devices that all depend on multicast. So I get a ton of multicast traffic constantly. So the way to limit that, or to reduce the amount of that that's happening, is to enable this feature called IGMP snooping. What IGMP snooping essentially does is it's basically keeps track of all the members of a multicast group and only sends the multicast traffic to those devices. Just to give you an idea of the kind of traffic that goes on the network, I've just quickly spun up Wireshark. And if you look at Wireshark, you can kind of see that, a lot of the traffic has the multicast, the MDN, as you can see there, SSDP. So this is probably a Chromecast device right there. Well, 101010. So this is my Home Assistant. Uses SSDP, MDNS. You can see a lot of MDNS communication happening there. You can see multicast traffic going on there on even the IPv6 right there. You can see MDNS. You can look at the MDNS is my camera. So this is the Akara G3 camera doing MDNS. This is my HomePod mini MDNS right there. It's an extremely important protocol to enable, and it can easily flood the network. Ethernet destination of the one, and then you can get a lot, right? Imagine every single device doing MDNS. It's very important to enable the IGMP snooping. Another thing that I do on my own network that to help with this is because even the IGMP snooping is not good enough to minimize the amount of multicast flooding that's going on. I've done something called the multicast storm control on my device. So if I head over to my switch and then the interface that has my access point, you can see I've enabled a multicast storm control and limited it to just 100 ppk. And if the traffic starts to hit 100, right, it kind of just discards it. It's bad in a way, so it might end up resulting in disconnections or lost packets, but I'd rather that than my entire network going down all the time, because it keeps crashing, right? So it's a little bit of a price to pay for a reliable and stable network. But when it comes to enabling this, right, I don't need it on the default. You want to enable it on just your main and IoT. And if you have like a media VLAN as well, you probably need to enable it there. So I have Reolink cameras and other third-party cameras. So You might need to enable it for that, but if you have just Unifi cameras, you don't need to enable multicast or IoT discovery for those ones to work. Anywhere where there's massive amount of multicast happening, so we probably need that on the camera as well. For the IoT discovery, we only need it on main and IoT, and save that, apply changes. And if we go here, you can kind of see I've added just enabled on my IoT, main, and camera VLAN, right? Those are the only 3 networks I use multicast on. But in this other case here, where we have a media VLAN, right? I have media enabled as well, IoT and main. I have it temporarily set up here because, again, I have not moved the native VLAN over yet. I'm still in the process of doing the move. We don't really need to worry about any other option on this page. Leave that option alone, and now we can proceed to setting up the Wi-Fi. Go back to our test environment again, and then we'll head over to the Wi-Fi component. But again, this is not active because I don't have any Wi-Fi device, but we're going to pre-configure it. We want to create an all new Wi-Fi, and then I just create something IoT, and then I just put a password in there. And then under the network session, this is where it gives us the list of all the the networks we created earlier on. So now we can assign it to the IoT VLAN. All right, and then again, like I said, I don't like to use the auto mode, so we're going to use manual, and then 2.45, and then I disable band steering, keep the Wi-Fi enabled. I want to be able to see the Wi-Fi name. We don't want device isolation. We don't need proxy app, BSS transition. And keep that. I try to keep that off on my IoT VLAN, right? The IoT VLAN, essentially, the goal is keep it as basic as possible, because this is the lowest entry for any device. The cheap smart switches, those low-end sensors that have the crappy radios. So you want to make sure that this thing is the most simplest as possible, right? No advanced feature. 2.45 at the most. None of these features enabled. We probably want to enable multicast enhancement as well, which is quite similar to the IGMP snooping as well. Helps with managing the flood of multicast traffic. So keep that enabled. We don't want to enable broadcast control, because if you do this, then you have to manually put in all of your multicast supported devices, so all of your Apple devices, your AirPlay, Chromecast. Too much work, so don't bother with that. And then we want to use the WPA2. All devices will support WPA2 at the very minimum. And then that's pretty much it. And if you have APs, you can do all of them or specific ones, but we don't have that enabled here, so we'll just add that. I'm just gonna put something there, PSS. There we go. Then we add our Wi-Fi network. So that's our IoT. I have one for the main, which is, just the general main for all of my laptops and phones and all that kind of devices, right? And then we'll put that on the main VLAN. And then again, manual, we don't want to enable that. I usually disable 2.4 on my main network. I want it to be just, high-end devices. Most of the time, my secure devices are not 2.4, so I don't bother wasting my time enabling this. Just keep on 2.5. And then band steering enabled. You don't have to worry about that because only one band is in use. And of course, we don't want to hide the Wi-Fi name. BSS transition, we keep that checked because all the newer devices actually support BSS transition, so you don't have to worry about that since it's a high-profile SSID. Fast roaming, you probably need this if you have multiple access points. If you have only one access point, there's literally no benefit from this. Of course, multicast enhancement as well. Ideally, you want to do it at just WPA3, but depending on the types of devices you have. Most of my devices will support WPA3, so I can disable WPA2, and then we'll add that there. Create a new one again, and I like to create one. This one is like my iPower. I just say HP, right? So this is where I have like the extremely newer devices, like something like my Pixel 9 that support the latest and the greatest in technology. In that case, usually it will still be part of the main. So with the main, you can have multiple SSIDs attached to the same main network, but have different Wi-Fi profiles, right? Disable 2.4. I'm just going to head over to my live environment, and then we go to my Wi-Fi network. So now we can kind of see what I was talking about, right? So this is my high performance network. If you look at my high performance network here, right, you can see I have MLO enabled. Now this is a relatively brand new feature that only very, very, very new devices support, right? You don't want to enable this on your IoT network because this is going to break stuff. So many devices don't support this. So I created a specific SSID just for that, so I can, play with that feature and functionality on this guy. You can see I only have one device there, which is probably just my Pixel phone, right, that supports that. And then I enabled just 5 and 6. And if you look at my IoT network as well, I only enabled just 2.4 and 5. Most of them will use 2.4, but I kind of put 5 there for anyone that supports 5. And then on my main, I have 5 and 6. And then I have one for my security camera, which is basically just my doorbell. Unifi G4 doorbell. So basically created one for it. But what I did differently here is I eat the Wi-Fi name. So if we go on my Wi-Fi, it's not going to show up on my Wi-Fi network because I've eaten the name. So no one is going to know that it's there, just me. Some of them I customize, like this one now, this one only lives on one AP because I know all the devices that are connected to this guy here, they are all in the basement. So there's no point in having it on both APs since I know that they are all in the basement. So they will always be connected or need to be connected to the basement access point. So those are unique scenarios where I go with the specific group instead. And then I have this high performance one where I only went with my U7 access point because I know that's the only access point that supports 6 gigahertz band and supports the MLO as well. So I kind of just made it specific in that case. But other than that, every other one, IoT is on all of them, right? And it's just 2.4 and 5. So that's pretty much how I have set up my wireless network as well. Basically a recap of all the things I showed you during the initial setup on my live environment, right? Native VLAN, management, basement, camera, IoT, main and default. And then I only have IoT main camera for IoT discovery, and then multicast I kind of just put all these ones plus the one that's not part of the IoT discovery because I know there are multicast devices in this group here, but they just are not getting shared from here into here because it's not on this list. If I put this and I put it here, then everyone in the basement will be able to see all the stuff, all my Apple devices or my Chromecast devices on any of these guys. Right now, these guys cannot see any of these guys, but all of these 3 guys can see each other's Aircast, AirPlay kind of devices. Alrighty, that pretty much covers everything for Wi-Fi and the VLANs